You just pick an epsilon. So take some epsilon greater than 0. What is my response to this person who challenges me with an epsilon?
Equation you start with.
Yeah. The whole point of discovery phase is that I now know precisely what to reply to such a person. I get challenged with an epsilon, then I set my delta to be 5/3 of whatever you just challenged me with. And now, what I must prove is this conditional. What I must prove is that if the absolute value of x minus -5 is less than delta, then the absolute value of f of x minus -7 is less than epsilon. And this proof is going to go very, very smoothly, assuming you've picked the right delta. All right, this is a conditional. How do I prove a conditional?
Assume the antecedent would be the consequent.
Yeah, assume the antecedent and derive the consequent. So I'm going to assume that the absolute value of x minus -5 is less than delta, and I hope to prove this fact. Okay, this time let's do it the absolute value-y kind of way, because it's just so easy. I just can't resist. So, what should I do?
Make it so it's x plus 5 instead of minus -5.
Okay, yeah, and?
Delta of like 5/3.
Yeah, plug in my formula for delta, right? I know what delta is. Delta is defined to be 5/3 epsilon. Okay. Now what? Multiply both sides by 3/5. So I get 3/5. Absolute value of x plus 5 is less than epsilon. Okay? Put the 3/5 in, she says. So we get 3/5 x plus 3. And then just rewrite, is that one cool? Then just rewrite this expression as 3/5 x minus 4 plus 7. Or maybe I'll just do plus 7. And then that's exactly what I want because that's my function. So what I've really just showed is that the difference between my function and -7 is less than epsilon, which is the consequent. So I proved the conditional, and I did it for an arbitrary epsilon, so the proof's like done. All right, can you guys handle this? I feel like you can. All right. Let's do like one more problem on this review packet, then call it a day. What else? What should we do? Um, 14?
Yeah.
I want to do 14? Okay. Okay. 14, the limit as x goes to 2 of root 6 minus x minus 2 over root 3 minus x minus 1. All right, who raise your hand if you got this problem? Yeah, what'd you do? Ron, what'd you do?
I multiplied both numerator and denominator by root 3 minus x plus 1, and then after that I multiplied the result by root 6 minus x plus 2 over root 6 minus x plus 2.
Yeah, this is really just kind of an algebra nightmare slash joy. So yeah, Rohan says first of all he tried to plug in 2. He got 0 over 0. So then he decided, well, I'm going to multiply by the conjugate. That should solve all my problems, if only that were true. In the denominator, I'm going to get 3 minus x minus 1. So what is that? Wow, this is looking hard all of a sudden. 2 minus x. 3 minus x minus 1 is 2 minus x. And on the top, I'm going to get a bunch of stuff. 6 minus x minus 2 times root 3 minus x plus 1. But unfortunately, my numerator is still 0, and so is my denominator. Did some of you just start crying now and like give up, or maybe you just like got angry or didn't notice, started, I don't know. Okay, so then Rohan says, I just continue. I will now just multiply the top and bottom by the conjugate of the numerator. Seems like a good idea. That's what he did, right? He's not even listening to me anymore. So yeah, root 6 minus x plus 2 over root 6 minus x plus 2. I haven't done this problem in a while. Does this work out? I feel like it works out now, right? Because now I get 6 minus x minus 4, which is 2 minus x. So I get 2 minus x in the top times root. Are you guys following this? There's really not much deep going on here, actually. The problem just requires one more step than you probably felt like you needed. And now I can cancel those, and it's no longer indeterminate. So the answer you get is like 2, 1/2? Is it 1/2?
Yeah.
Okay, that's pretty cool. All right, anything else? The rest of this, you feel like you can handle it? Yeah, Sydney.
The answer key gonna be on Edline?
The answer key could be on Edline any time that I deem it should be. Probably like now would be a good time, right? Like soon? Yeah.
It's
Okay, there is a review session after school tomorrow, as there is every Tuesday. So that's happening. So you should come maybe and finish the review packet if you haven't by that point, and we can go over certain problems or whatever. All right, can we just close limits for the moment and move on to something more exciting? Test is on Friday for you guys, yes. All right. So, Calvin.
Can I get a drink of water?
Yeah, the worst possible time to go get new water, but yes. All right, and Arun, can you raise the backboard?
Yep.
All right, finally something kind of exciting. We've had sort of, the last 2 lectures have been like a little bit boring. And I don't know, the last half an hour is like a little bit boring too. And also I'm kind of sick, so I'm sorry if I'm not giving everything my usual level of enthusiasm. I will fake it. So, what am I doing? Okay, what are we doing? We're going to, well, kind of limit, but kind of not. Yeah, we've kind of just been, Emma, we've sort of just been screwing around the past like 3 weeks in some ways, right? We learned, well, what have we, how would you tell somebody who was not in calculus? How would you tell your, like, 8th grade little sister, like, what have you been doing in math the last 3 weeks?
Limits.
Yeah, limits, but then she would tell, like, what are limits?
And then I just give her the definition you gave.
Okay, Mateo would start giving the 19th century Weierstrass definition of the limit to his 8th grade little sister. But Mateo also doesn't talk to his parents, so that family, who knows what's going on. Alright, no, seriously, how would you explain what we've been doing for the last 3 weeks?
Trying to define continuity.
Yeah, I kind of like her answer, infinity. We've been basically just messing around with infinity, right? That's in fact what limits are. Eob, your answer is also good. You have been talking about continuity, that's true. But primarily, in spending so much time on limits, doing so many limits of all the tricky varieties, and talking about, oh man, 0 times infinity, what is that? Oh, I thought I knew, I don't know anything anymore. Okay, what we have basically been doing is investigating precisely how tiny, tiny numbers and huge numbers interact and how they can be sort of added and subtracted. Okay, so we've been learning as sort of a mathematic, or arithmetic of infinity, so to speak. Okay, but that has not been part of our central problem. We set out to solve some problems. What were the problems that we set out to solve? The area problem and the tangent line problem. Okay.
I was wondering about those. Like,
you're actually wondering about that. Yeah, when are we going to get that? Answer now. Sydney, here we go. The tangent line problem. We are going to solve it pretty much in the next 5 minutes.
Part 2.
So, what is the tangent line problem? Can I get an explanation very quickly of that?
Okay, let me just flip back.
No, without looking at your notes, let it come from your soul. Eustace, the tangent line problem, what is it in a nutshell?
You want to find the slope of a curve at a single point, and to do that, you use the tangent line to that point.
Yeah. The tangent line problem says, given an arbitrary function, given an arbitrary point on that function, let's call that point A, please find the slope of the tangent line to the curve. And the tangent line to the curve is kind of like the one which is sort of doing like this, right? Touching the curve at exactly one spot. All right. Oh, a word about notation. I can't remember. Is this the class where I tried to do Latin and it failed? Or that was a different class? Oh yeah, good. Does anyone speak Latin here? Does anyone study Latin? Oh. that in elementary school. Okay. If you actually know that, then it gets more complicated because I can't just make things up. But I think we checked this. I think someone got out their phone and we checked this. We checked this story. So the word we keep throwing around this word tangent line. So maybe let's just talk about that for 5 seconds. So back in geometry, I might have even talked about this in the first day school. Back in geometry, you had circles and you had tangents, right? So that was called a tangent line. And when you have circles, it's very obvious what a tangent line is. It's a line which is touching the circle at exactly one point. Yeah. And you can prove all kinds of happy things about the tangent line, like that it's perpendicular to the radius drawn to the point of tangency. So this is a tangent line, and we call it that for some Latin reason, which I believe is something like, there's some kind of word like tangere or something like that. Does that mean touch?
To hold or touch.
To hold or touch. Yeah, see, I know how to use the internet. So this means like to touch or something, to touch or to hold. So this is like the line which is touching. So it all makes perfect sense. And then there is this line from geometry, the secant line. The secant line is the line which is cutting the circle in 2 points. Okay, here's where it got controversial in the 3rd period because the girl, I thought that this was Latin for cutting, but she didn't like that word. But there's some word like there's I don't remember who it was. But it was like Friday. But it was something like I want to say like Cesare or something like that. No, that doesn't make any sense. Secare, I think that's right. Oh man, I need to research this. I think Secare. I don't know Latin. Was that a word?
I'm looking it up.
Oh, Calvin's looking it up.
I wasn't very good at Latin.
I feel like okay. I feel like this is to cut maybe. And if not, don't tell me. So the secant line is a line which is cutting through the circle. Okay, so that's the first time you heard these words. And what was the second time? Is that right?
It means to saw.
To saw. Great.
Great.
But that's the right word?
You want me to look up to cut?
No. Okay, good. But that is a Latin word. Secare, like that.
Yes,
I'm not sure if
it
we're pronouncing
is.
it either. All right, but no one pronounces Latin anyway. All right. So don't want to waste too much time. When's the other time you heard these words coming up? Trig functions. Thank you. And we discussed, and I got mad because I realized that Giles never told you this, but it's really well. I don't know if it's important or not, but it's definitely cool that the trig functions, we use the word secant and tangent for our trig functions in the following way. That if I draw an arbitrary, so here's the unit circle. If I draw an arbitrary angle here, and then I extend from the point 1, 0 a tangent line to the circle, then a triangle is formed, and the sides of this triangle can be represented with the trig functions. Because this is just 1, because it's a unit circle, and then what is this vertical segment here? Yeah, that is tan theta, because, well, tan is opposite over adjacent, so tan theta is that over 1, so then that must be tan theta, yeah? And this is, well, secant is the ratio between the hypotenuse and the adjacent, so the secant of theta must be jump over 1, so therefore this must be secant. And this is the geometric proof of the Pythagorean identities for tan and secant. Okay, cool? Cool. So the tangent line problem says find the slope of the tangent line to the curve. All right. How do we do that actually? We kind of fake solved it on the very first day of class, but then we just sort of pulled back at the last second because we didn't have the vocabulary to describe it precisely. But what did we do? Remember there was a whole conversation
About like going to
Cop
New
cars
York
and stuff.
stuff.
Yeah.
That
Yes,
was
going to New York, but it was sort of later than that, right? It was what even do I mean? What even do I mean? Because remember, what was the point of the tangent line problem?
Instance of velocity?
Yeah, the instantaneous velocity, right? If this is some position versus time curve, then the slope of the tangent line to the curve was, we decided, the instantaneous velocity. Yeah, why was that again?
Find the slope of the tangent.
Oh, you guys aren't cooperating. Sandeep, how do we do that? How do I find the instantaneous velocity? Hey, Mateo.
You take like a secant, you take 2 points, and then you take those points closer and closer and closer together. and eventually it becomes so small a difference that it's essentially tangent, or you make it the same.
Yeah, Matteo says basically, if you would like to find the slope of the tangent line to the curve, you kind of can't. You have to just fake it. And so what you do is you pick a new point, x, which we think of as being very, very close to A, so picture not to scale. And then I can plug some things in, right? This point is like A comma f of A, and this point is like x comma f of x. And, well, if this is a position versus time curve, I can now ask the question, what is the average speed on the time interval from A to x? Remember we did this on the first day? And what is it? What is the average speed on this time interval? Someone new who hasn't talked yet today. Megna. Steven.
Just like rise over.
Pretty much, right? It's rise or run. Average speed is just total distance over total time. What is the distance traveled over the interval from A to x? Well, the distance traveled is f of x minus f of a. Because, and there's kind of some triangle hiding here, right? Yeah, we did. I think we did this exact thing on the first day. The triangle f of x minus f of a, f of x minus f of a, represents the amount that the new amount of distance traveled, and then the x minus a represents the time elapsed. So total distance over total time. And geometrically, so Stephen said rise over run, but okay, rise over run of what?
It's a slope of
It's the slope of what line?
that one.
The line I haven't drawn yet? Yeah, it's the slope of, yeah, it is the slope of something. It's the slope of the line through those 2 points, like so. Yeah, and we have a name for this. We call this the secant line. So the secant line is just like from geometry, it's the line which is cutting the function at 2 places, the line which goes through 2 points. So the slope of the secant line is like the average, rate of change over that time interval. And we give this quotient, this is sometimes people call this difference quotient. Difference quotient. Okay, but I don't want to know the average speed over the interval ax. I want to know the exact speed at x. So how do I turn a secant line into a tangent line? Okay, now the whole class, just rebound. Eric, what do I do?
We make it closer and closer.
Closer and closer. How close?
As close as you want.
Yeah, really, really close. Okay. Yeah. So in fact, I think we're just prepared right now for me to tell you what the slope of the tangent line is. All we do is we take f of x minus f of a over x minus a, the slope of the secant line, and
Voila.
no, not voila. I haven't done anything yet.
What?
The limit of that is x goes to a.
Yeah, we take the limit as x goes to a of that expression. And a limit is a number. All right, tangent line problem solved. You basically just take a fraction and then you take a limit.
Wait.
That's really it. That's actually it. The slope of the tangent line to a curve is just the limit as x approaches a of the slope of the secant line.
Wait, so why did you wait so long to do this?
Oh, we didn't really. We didn't really.
Yeah.
We could have done this on the first day school. We basically did do this on the first day school. I've got it all the way here. I just didn't write the word limit, but otherwise we basically did it already. Okay, so before you even have time to process that or anything, I will now draw. It's kind of exciting to watch them all. They're so cute. They don't know anything. It's so funny. Now I will draw a very similar picture. In fact, it is the exact same picture. I'm just going to use a slightly different notation. So here is a function. I am still interested in the slope of the tangent line, and I am still going to do that via the same method of finding a point which is a little bit bigger than a, but now instead of calling it x, I'm going to call it a plus h, where I think of h as being a tiny number. Okay, so someone talk to me. What should I do? Same thing, yeah. Can you be more specific? Mateo?
It's like the same thing, but as h goes to 0.
Pretty much, yeah. Can we, so, yeah, and Mateo's kind of just done already, right? So we can just label up this picture, you know, this is going to be the point A, comma, f of A, and then this is going to be the point, Magna, what's that? What's that point? Yeah, there's no cooler way to write it, just like that. And so, again, I can ask what is the average rate of change over this very small time interval. Well, everyone just write it on your paper, and I'm sure you'll be right. Over that very short time interval, the function went up by f of a plus h minus f of a. Agreed? And how much time elapsed? So, yeah, I just forgot about this whole table. Kendall, what is thus an alternate way of expressing the slope of the tangent line?
And the limit as h goes to 0 of f of a plus h minus f of a over h.
Yep. Exactly. In order to get the slope of the tangent line, I take the slope of the secant line and I move that point infinitely close to that point. And that, for us, with this notation, that means basically letting h go to 0. Is everyone cool with that? All right, let's do one. So now we're going to solve an actual math problem. So here we go. Take the function f of x equals 4x squared plus 1. Task. Find the equation of the line which is tangent to the curve at x equals 3. Find the equation of the line tangent to the curve at x equals 3. Do it? Or that's it? Okay, so maybe finish, because it should be a number, right? Got an answer compared to the person next to you?
Yeah, no idea.
Oh, and by the way, there are two different ways to do it, right? So you should try both ways. You should be equally comfortable with both ways. So I draw myself a little picture every time. When I plug 3 into this function, what do I get? 37. So Cindy, if I was doing this in a particular way, I'd draw myself a little picture, but I don't bother making my picture actually accurate. This graph is not accurate at all. This is like a sort of a schematic. You know, just to get me sort of thinking, especially in the beginning, before you're an expert. So you just kind of draw this out, and then that's the slope of the secant line. But what I want is the slope of the tangent line, and so this is the limit as x approaches 3 of the difference in the y's, which is f of x minus 37, over the difference in the x's, which is x minus 3. Is that what you guys did? Supposed to do? Okay, now it's just a matter of doing a limit, and we're all like experts on limits, right? So that's why, whoever was asking that, I guess that was Sydney or somebody?
Yeah.
It's better if we just, it goes easier at least, if we just become experts on computing all possible limits, and then we don't need to even sweat over this, because it's just like, dust. I've done this a million times. And of course, it's a 0 over 0 situation. So I do some algebra, and then suddenly it's not.
Oh, I like this.
Yeah, it's pretty fun. Did you get 24? All right. If not, start spontaneously crying. Whoa. Or give me a sign of some kind that you didn't get it. Calvin, you good? You got 24?
Yeah.
Yeah, good. You should be, Laurie, okay?
I did it the other.
Oh, you did it the other way. Good, because that's what I'm going to want you to do it both ways. I think it's important that we become a so if you did it one way, do it the other way also. No, do it for real, like fast. Do it both ways. Do it both ways. Everyone should do it both ways.
You do H.
Just do it with 0.
Plug in H plus 3 and then H2.
You just do what?
What you're doing
Yeah.
exactly? You're trying to solve the problem in general. I'm trying to solve this particular problem at 3.
Oh, I couldn't. Sorry, I got 6
Yeah, you just.
Oh.
Yeah.
Well, yeah, actually, so that's, no, you're right, I haven't actually finished the problem yet, just don't think the question about it. But, so then the other picture, it's no different, the logic is no different, but the algebra turns out to be kind of different. Is that what you guys are finding?
It's plus 36.
Actually, kind of works.
Because it's H.
Wait, what's H? Can you continue with H?
It's H plus 3 squared times 4, so it's
And also messed up.
the last number is a
You need to learn to love both of them.
I mean, this is sort of like it.
So this is going to be, again, schematically, the idea is the difference in the y's. So over the difference in the h's.
Then you just.
And you did it both ways? You got the right answer both times?
Are you ever gonna ask us for like one way or the other?
Just trust me, you need to know both ways. So, I guess I just need to multiply all that, right?
Yeah.
Oh yeah. 24. Yes. Yes. Okay. So now we have to do a little bit of algebra 1. Oh, by the way, before we move on, let's just appreciate how just awesome this is. We've suddenly done something which we just never could have done before. This was something that you may have wondered this kind of thing in pre-calc, and you were just had no idea what to do. So let's see. If I plug in 3, I get 37, right? So let's call that 37. If I plug in 2, what do I get? 17, is that right? Because it's too slow. If I plug in 1, I get 5. And if I plug in 0, I get 1. So what I have is some kind of parabola which looks like that. Agreed? That's my function. So this is just, y equals 4x squared plus 1. Suddenly I have solved this just like incredibly impressive and awesome problem of like infinity, which is I've now shown, what is the significance of this number 24? What is it? It's the slope of the tangent line. And it just all sort of looks and feels exactly right, right? That line is, it's like pretty steep right there. So yeah, this is this line, the line which is tangent to that curve has slope 24. Cool? I think it's pretty cool. Alright, so I actually asked you, however, not for the slope, but for the equation of the line. So we do a little bit of algebra 1. The equation of the line, therefore, is y minus 37 equals 24x minus 3. That's the simplest way to do it. And you just leave it like that. Eric, be good. Okay, go, let's do another one. Find the... Do we have time for another one?
Maybe.
Yeah, we do. Find the equation of the line which is tangent to the curve at x. Given new function, the new function is f of x equals 1 over x. Find the equation of the line which is tangent to the curve at x equals 4. Find the equation of the line tangent curve x equals 4. Yeah. And do it both ways. And like I was saying before, I think it's helpful in the beginning to potentially draw yourself a kind of a picture which is not necessarily accurate whatsoever, just to kind of remind yourself, sort of what's going on. This is what I do.